So first one, when we talk about NFVI, actually we are putting a bigger context why we are doing NFVI. That's all related to the cloud transformation. The cloud transformation is for Telco is not only to use IT technology, it more means innovation in carrier side. If you look into more detail, that can be categorized in through domain. So usually when we talk about introduce cloud technology, we are focused on network side to do the network innovation, but also operation innovation. When you build this cloud platform, how you make streamline your process, how you make it simple, that also is important. And that one is for carrier. Today we are selling the voice sales bandwidth, but in future that's not enough. So all three, the transformation need to be covered all three of these areas. 5G, why 5G is so important? Because 5G, by providing this massive connection, ultra high speed and low latency, it can help operator to take use of this new technology like AI, like IoT, and together with 5G. So operator will be on the central role to help each vertical market. If we look back to the history, NFV is not some new things. NFV actually, we started quite a long time, but as all of this new technology, you have the uptime, you have downtime. But as we are observing and working with our customers, we see NFV now is in a key time phase that's going to above, going to fly. And we already accumulated a lot of experience in the past few years. And we believe now, in 2018, now we are ready to, together with the customer, to book NFV in a massive deployment. If we look about Huawei ourselves, Huawei, as you know, we are focused on the telecom communications. And for telcos, it goes through several periods when we start. If you're looking back at year 2000, in that time, most of networks are still TDM based. And we're moving from TDM to IP, and we have so-called all IP strategy to build our product fully on IP. And after 2010, that's a new wave coming, that means cloud. And so-called we define the software comm that's equal to software-defined telecom, and to use the cloud, use IT technology to transform our own product, make it more efficient, more performance to our customer. We already get more than 1,000 practice in the softcom, which include NFV, SDN, manual, all these kind of things, which to build the basic component for build the future approved this NFV solution. And inside of them, we have count 350 NFVI commercial contract with our customers. And that definitely make us in the leading position if you look into the global market. What we see is a obvious change that when telco are built cloud, no matter where they start, they may start from platform driven. That means you build platform first, then you consider to move application by application. Or you can do vertical part by part. You focus on one application and make it running perfect on the NFV platform. And in future, you are going to think about how to connect it together. So you can go either both direction, but finally you will have reach same destination. So have this all cloud network with unified NFVI platform. And that platform should be flexible enough to cover multiple locations and also to enable to connect with up layer your management orchestration system to reach the service automation. With the cooperation and engage with our customers, we see there is a major three challenge, which Every time I go to my customer, they will ask this kind of question. How I make sure when I do a virtualization, my system is still running and provide me 5.9 SLA. And what is, in future, if I want to add more, so what's your plan, how you're able to do that? The last one is the most challenge or is most frequently mentioned is the multi-vendor. So in the past, you have the so-called all-in-one box that you turn on, it works. Now you have virtualization, you have hypervisor, you have codes, different server switch, and VNF from different vendor. That makes such a complexity, which you need to spend more effort in the integration and even in future when you operate the network. So the carrier grade NFVI should be addressed and answer these three questions. That was for NFVI, for what we see today, the service. But if you look into the future, when 5G comes in, the first hot topic is MEC, edge computing. So how we do edge computing? Edge computing in Telco, that's more user name MEC, mobile edge computing or multi-access edge computing. That gives a capability to extend the cloud from central to the edge. So together with the network information, contact, location from network, so we are able to support a lot of new business. For example, there is the smart stadium that you can have the offloading the stream follow from the location directly that gives better experience. Also, you can do the on-site video analytic that in this case, you can do the processing on the video and the image without sending back to the central site. Another, based on traffic local readout, we can help operator like the oil field or this ferry, they build their own network directly. The last one, also the V2X is so important. Actually, V2X is viewed as the most important application for 5G at this moment. Besides the network change from central to the edge, we also need to think about how in the future the application looks like. Today, most of VNF still on the VM form because the Telco supplier, they have a lot of application which existing that easier to map into the virtual machine. But in the 5G, we need to build the slicing network. So operator will be to easily to split the network to fit into different vertical market. That needs more flexible on the resource on the infrastructure layer. So microservice architecture will be a destination for future VNF design. So the platform for NFVI also needs to address that to provide the platform, the environment for this container-based technology. More than that, if we consider the CI/CD together, how we make streamline process from development to test to the production side. So that also needs to be put into consideration in here. So how we build cloud-native architecture with the performance of multiple massive processing, but also consider how to application to more reliant and easy to deployment. The last one I want to talk about future is the hybrid cloud. Hybrid cloud is not naturally from today's business, but if we look into the future, when Telco are going to provide service besides the voice and bandwidth, you need to work more closely with the virtual market. There are a lot of applications already on public cloud. So how we do build bridge to them, making them easily to move application between public cloud and private cloud. That you need to consider to bring in the hybrid cloud technology. So that above was our understanding for future for 5G. And here we talk a little about our solution. So Huawei solution is based on the OpenStack, and you can see in the central part is the standard NFVI structures, which complies to H standard. What makes us different is in this right side, we have this NFVI OM, especially enhanced not only Vim, but we also put in the physical device management and a part of a service center, the management service center, which provides the VDC management and also provide the resource allocation quota management, which can be linked together with the operator internal organization. That make it easier. You can help you to build how you manage the cloud itself. For the NFVI solution, the openness is a must-have. And what we ensure openness is from two directions. One is from southbound, we use standard interface to monitor to manage the code's hardware. But more importantly is on the northbound interface to talk with different VNF and VNFM. So make sure any third party can be running on that without faultless. For Telco grid side, we can divide into four aspects: performance, reliability, management, how easy to operation, and last was how easy to evolution. Inside of these 4 points, I think reliability is most important. Is what you start to build the base. But you're looking for the future, then evolution is also a right part to take more considerations. A few words about the performance. I believe you already heard about from different providers. So what we do on performance, that we introduce quite a lot of technology like this CPU bonding and the NUMA hoop page, SRIOV, and for EVS we have enhanced overswitch on the open switch that can give the 40% higher interface performance gain. Basically, that means you can use the same hardware for take more traffic. And the last one is for interruption aggregation. So by this, we can build the VM, which is specific with low latency and more precise on the timer. As you know, in the Telco application, a lot of VNF, the service based on high precision on these timers. For example, when you do the transcoding, then the timer is very important. So with this technology, you can assign certain VM special for the transcoding. Another thing to mention for the performance is the FPGA, hardware acceleration. As we did the experiment with this VBRAS, what we find today is based on open standard server, still we have a big performance gap compared to the traditional specialized hardware. So in the data plan forwarding applications, the hardware acceleration is a must-have in future. And also if you consider in the edge computing, and you need to provide such enough capability in limited size about your footprint, the product. So in future, the hardware acceleration will be more and more important. For reliability part, here we want to mention two things. One is we have some enhanced fault detection. So we can reach 1 second. That means when there is a fault in hardware layer, in virtual machine layer, so our management system will detect and be alarmed within 1 second. That is basic to give you to allow you have more time to response and to have less time for interruption. Also for virtual machine migration, so what we did the first rebuild. So once you set up this HA capability for the VM pairs, so we can rebuild it in a few minutes. That was a maximum for 3 minutes. What we tested recently with our customers around 15 minutes for a normal VM. Oh, sorry, 15 seconds. In the disaster recovery, that was also cared about by our customers, especially. We can do the disaster recovery between two sites. We can reach the cross-DC full-site disaster recovery. That means when you deploy the application in multiple sites, and if one site was down, but we can very soon to boot all the application in another site, so it will enable you to get better management when the disaster coming. This feature is especially used for the new application you want to introduce in your platform. So we see in Telco application, traditional suppliers, they have already built quite a mature mechanism on the application layer. So they don't need such a feature. But to build on the application layer is quite complicated. And most of new VNF vendor, new application provider, they don't have such a capability. So with these features, we can help them to easily to design and make this high availability mechanism. And this feature, when we provide it, we provide as a service. So based on in this cloud management platform, you can configure the service to the tenant if they use this high availability. Also, we provide the backup, remote backup is together. In terms of the operation part, what we see today's most challenge is when the operator go to OpenStack. If you run a standard OpenStack, you need quite skilled people to manage the component and to understand a lot of details in how you bring the OpenStack wrong and to find where is the wrong configuration if there is a problem. So what we do is we build quite a lot of tools to help the operation and the deployment. One example is today we can do with this automatically installation. So that means when you set up the hardware, you configure the software will automatically discover the hardware, and also we give the graphical interface for your operation team to configure, to provision what you need on the cloud. And also we give the tools to help to do the health checking. Like say, when you have some important change or you want to do upgrade, you usually need to do a routine check to check how the system working and if I'm ready for upgrade. So all this can be packed on the deployment and the operation tools. One example is in the production level, we test and verify. We can do the full upgrade within 5 hours for a complete cluster, which include all the upgrade on the host nodes. So average, each node can take 10 minutes around. And that's without any command line involvement. So your operation team, they don't need to be the expert to run it on command line. But that was 10 times improved compared to before. Usually you need skilled people for 5 days to finish the same amount of work. Upgrading and patching is another challenging issue. So we also provide the updating tools. So you can define how you want to do the patching, how you do the upgrade. And also we support to the rollback. So if there are any problem, you can always roll back to a previous version with exactly the same configuration, just like nothing happened. That was another example we did within 2 days. We finished 17,000 node production with such tools. So all these tools it's not so great on technical advantage, but it do solve your daily issues, how you manage and how you operate. The last one about the OM is when you are running an NFVI system, you are not running one OpenStack. You are going to build a network covering to multiple sites, and the resource need to be centrally managed and operate, taken into a single pane of glass. So the operation center inside the cloud management that give you a unified single entry point for this alarm, logging, and topology analysis, all these things. And that also be an anchor point to link into your ITSM system and also to up layer OSS system. The last thing is, as a virtual machine and this kind of things is quite abstract, and usually you will need a very good understanding to understand what happened. So what we do is we collect all the information from the IP connection, from the port, NIC card, virtual machine, and the host. We put all the information in a more graphical way. So in case of there any network fault happen, you can identify directly on your operation panels. And you can find, let's say, if there are virtual machine to virtual machine communication is an error. Then you can look into the system to find exactly to which part where it calls and what is the suggestion to you to bring it back to a normal state. In longer term evolution for the infrastructures, so we see we will go from single DC today in most of the case to a multi-tier DC structure to cover more country, more areas, and the structure from center to the edge to introduce edge computing. And another thing is to introduce a platform as a service. Here, major means the cloud native support, and also to add big data database as a service, if that fit to your business plans. And when we go into that, then that also build a solid foundation for your cloud, Telco cloud, not only for your today's Telco application, but also for future, for enterprise or so-called IT applications. In this way, you will have a unified cloud infrastructure, and for that finally will help you to reduce the operation cost. So in terms of the platform and service, we have a package called the Fusion Stage that provides the container-based support and also with Kubernetes cluster management. So that platform, that package will be running together with our OpenStack. Basically, how they work together is all the resources will be managed by the OpenStack. So this way, you still keep your investment. You have a central point to manage all the IT infrastructure part of the resource. And the other part, the container management, will leave to the platform as service. So by this way, that especially to help you not to create another separate room in your IT network, and also to give you easier for integration to ISDN and also storage plan. In terms of the edge computing, there could be quite a lot of design, but all the considerations should be fit to three areas. First one is for the device, for the platform in the edge side, need to be light enough that you can have different form of hardware and to fit different purpose. For example, today most of you will use standard server, but in future you may come to the customized server or special server which you fit into on the outdoor deployment or on the vehicle. And for the performance side, there could be new technology like FPGA, smart NIC card, or GPU to be fit into such a computing platform. And in the last one is that so many edge sites usually take 10,000 or 100,000 could be that need to be considered how to management it to together coordinate with your central cloud you have today. For the last word is for the hybrid cloud. That hybrid cloud can give you a unified API. So with the central cloud, you can manage your own cloud. That means private cloud, but also in the resource in the public cloud with the same interface. And the application can be moving between the Telco cloud and the public cloud. Also, the artificial intelligence is important, and we are going to move in that capability to a private cloud as well. And then with this, like TensorFlow, this AI platform, we are going to give you NLP and image voice its capability that help you to support different application in virtual market. Inside the Telco, that could be helpful on the to do prediction the traffic, to help you find the fault easily, and also to increase the user experience. And also that could be fit to the vertical market with your partners. So after the softcom, software-defined telecom, the next one is softcom AI. So softcom is for today, and softcom plus AI is for next step. So that came to very short about my presentation. So for the future NFVI, how we go to 5G, and also even for today, how you build your NFVI platform, I think career grid and the evolution open is 3 keywords we want to recommend it to you. So that's all about my presentation. I'm happy if you have any particular question, we can discuss together.